Okay, so in this demonstration, we're looking at two different kinds of waves, and we're using the slinky as an example. So let me just go ahead and show you the first example. So I'm squeezing this obviously together, and notice that as I push this part together, the other parts spread out. And now watch what happens when I let go. So you can see the slinky, the material itself, moved back and forth, indicated by this line. And also the energy that I put into it moved back and forth from me to Sean and back. So the material went back and forth, the energy went back and forth, they're parallel to each other. And this is what we call a longitudinal wave. And this kind of wave will move through a solid, a liquid, a gas, and plasma. And it's also the way that the primary or P earthquake wave or seismic wave moves. Okay, now Sean, hold the end of the slinky just like this. Don't move your end at all. I'm going to move my end up and down just one time and watch what happens. Okay, so clearly the slinky is moving up and down, indicated by these two lines. Okay? But I started it by moving it up here, so the energy traveled from me to Sean and back. So the energy is going back and forth in this direction. The material is going back and forth in that direction. So they're perpendicular to each other. This is called a transverse wave. And an easy way to remember it is the sign for perpendicular looks similar to the T. And this kind of wave will go through a solid material, but as soon as it hits a liquid or a gas or plasma, it's going to stop. And this is the way the secondary or S seismic wave or earthquake wave travels. And it's this difference that enables us to know that the outer core of the Earth's crust is a liquid because these waves stop there.